Okay, here we are at topic 17. Picture this. And this has to do with schematic diagrams. I kind of put this up the other day when we were doing some of the other electronic stuff, just to kind of give you a little indication of what some of them look like. I don't know how well you can see any of this, but on this particular chart, and I think it's also up in the Dropbox. Um, If you have access to it, if you don't have access, let me know, but if you have access to it, you can easily download this stuff, for your own reference as well. I'm perfectly okay with you downloading any and all that stuff in that Dropbox if you want, but, we have the different resistors, different capacitors, different inductors. We also have tubes in here, some of the tube elements, referred to, different types of, wiring indicators, like for terminals and multiple conductor cable. The different types of switches, some that are multiple tap and multiple throw and things of that sort. Incandescent lamps, those little seven segment displays that used to be on the clocks were quite prevalent back in the 70s and so on. Those were incandescent lamps. Symbols for grounding, symbols for components within integrated circuits, and more uh, indicators. So, well, these are relays, which show single pole, single throw, or double throw, double poles, stuff like that. And then over here we have, of course, our diodes, different types of diodes that are available out there, the Zener, Schottky, tunnel, LEDs. LEDs are just a light emitting diode, bridge rectifiers, things like that. Transformers. I'm going to talk a little bit about that this evening as well. Um, some miscellaneous stuff, fuses, ceramic resonators, antennas, things of that sort. And then phone jacks. We're not really going to cover tonight at all. The different types of transistors that are available, and then logic circuits within an integrated circuit or an IC, battery symbols, and different types of connectors. So that's a little helpful little uh, chart for you to kind of latch on to and utilize. Um, Transformers, I'll bring those up, different components again, all this stuff. I'll be bringing this stuff up as we go through the lesson material. But I'm going to go ahead and get started here real quick. And some point here, I'm going to pause and I'll show you some of the test equipment that I have. Uh, and not everybody has test equipment. The basic test equipment that I really um, encourage any ham to have in their shack is at least like a multimeter. You can use what little knowledge you might have at any particular time to, check the voltage of your power supply, things like that, connectivity, conductivity, things of that sort, and also an SWR meter, so that you can make sure that the conditions for your transmission line and antenna is optimal or at least acceptable to your transmitter. So an SWR meter is a good thing to have. All right, we're going to start here with topic 17. And of course, this is kind of a simple one here. What is the name of an electrical wiring diagram that uses standard component symbols? Well, we know that a bill of materials is basically a list of things of things being shipped, or a bill of materials of what might go into um, a shipping container or whatever. A connector pinout is something that's totally different. A flow chart has to do with programming, basically. But your correct answer here is the electrical wiring diagram is a schematic. So your answer is C. And it's a good idea to be familiar with some of the identifications of simple schematic diagram illustrations. And one of the things about a schematic is it does not actually show the component locations, say on a circuit board, but it does indicate the connectivity or how those particular components are connected together. That is one of the questions. What do the symbols on an electrical schematic represent? Well, that's again very simple. It has to do with your electrical components. And we just saw that chart that I put up there that showed the different electrical type or electronic components. And they use the word electrical. I like to use electronic, but Mitch being familiar a little bit more, he uses electrical components. So there you go. All right. Which of the following is accurately represented in electrical schematic? Again, I say it doesn't show what a circuit board looks like or the physical appearance of how they're mounted on that. That's a totally different animal altogether. But it just simply shows the way all the components are interconnected. So your answer is C here. And typically it shows right down to each and every lead as well. So what is component 3 in figure T3? And from our chart, of course, um, we know that component number 3 would be, you see that little arrow there. There's a little arrow, which indicates that this has some variability to it, that this is kind of an adjustable thing. So, and of course, the little curlies there would indicate that that's an inductor. So this is actually a variable inductor. So your answer is D on this. Little squiggly lines is what they call them. Um, it's variable because we see tap points on the hump lines, and a line with an arrow indicating the inductor can be adjusted to any one of the taps. Inside of an antenna tuner um, is typically an inductor, and most of them have a capacitor or possibly two capacitors. One is on the transmitter side and the other one's on the antenna side. And it also has a roller inductor. So your inductor, the combination of the inductor and the capacitor, basically make up a tuned circuit. But some of these have a roller inductor, which means that it's so variable that as you turn the roller on that coil or the inductor, it rides along that inductor along the wire itself, and but on some other types, it's a switch. It's not really a roller. It's a switch that actually moves um, to different taps, much like this one shows here. The variable inductor would be kind of a switched one, and you'd flip it from one to the other, and it would go to one of these taps. So it's two types of way to do it: a roller inductor and a variable tap inductor. Okay, what is component 4 in figure T3? And this should be fairly easy. I mean, when you look at this, you should automatically think, okay, one of the things I can tell you right now is that this is a tuned circuit. In actuality, this could very well be a very basic description of an antenna tuner. So again, it would be fairly easy to say that um, component number 4 up here is an antenna. And if you answered A, that is correct. It actually looks like an antenna. Okay. Which of the following is combined with an inductor to make a tuned circuit? Of course, I just alluded to this just a little bit ago and pretty much gave you the answer as being a capacitor. A capacitor and an inductor create the tuned circuit. So we use various combinations of series and parallel coils and capacitors to develop the tuned circuit inside the radio um, as well as some things that are done externally. So another name for a coil is an inductor, and when used with a capacitor, you now have a tuned circuit. And again, backing up here to this diagram, that is what's happening here. An inductor and capacitor uh, make a tuned circuit. Had a little bit of a cough there. All right, here we go. Oh, I went ahead a little too far here. Okay, which of the following is a resonant or tuned circuit? Well, answer is A, an inductor and a capacitor connected in series or parallel to form a filter. And a resonant circuit must contain at least one inductor and one capacitor. Okay, what is component one in figure T1? One thing to kind of note, and something that might help a little bit, is that it's a little zigzag line. And you note that the shortest distance between 2 points is a straight line. And if you have a zigzag line, um, it automatically indicates that you're not going to get there from that point to the other end rather not real quickly. Rather, it indicates there's a little bit of resistance there. So really, that is the symbol for a resistor. It's a squiggly line, and imagine current flowing through all the squiggles, creating resistance. So I hope that helps you remember what a resistor is. So what is component 2 in figure T1? We kind of covered a little bit of this before. We talked about this happens to be an NPN type of component, but it's if you answered B, it is a transistor. The arrow is not pointing in, so it is an NPN transistor. What happens in this circuit is that you have um, a power supply here. This basically is a battery going to this little light, and the other side, of course, your negative going to ground. You have the in the negatively doped side of the transistor also going to ground, and of course, your positive flows to a negative. This is kind of like a switch. There's a current that is applied here, and when this kind of goes positive, it actually starts to conduct so that this completes the circuit. Transistor is like a little switch, or it could also be an amplifier depending on how it's configured. So this light would turn on. Back a long time ago, I was in the fire department and I built a little circuit that would basically using a 5-5 timer and a couple of transistors and some things like that. I modified my headlights so that when I plugged that circuit in to the cigarette lighter, it would cause my headlights to alternate back and forth on and off. So, and of course, I had a little light on the top of the roof. I was a volunteer firefighter, and uh, people would get out of the way. So, um, and that's what was happening is that it would pull this one side to ground and cause that to light, and it'd be switch off and on. So that's a transistor number two. What is the function of component two in figure T1? Okay. Figure T1 is here on the right-hand side, and we have component number two. And what is the function of it? Well, I pretty much described that here just a moment ago. It acts like a switch, but it controls the flow of current uh, for the light. It's much like a valve. As a matter of fact, old timers used to call tubes valves. So answer is C there. Controls the flow of current. So what is component 3 in figure T1? And we just pretty much talked about that. Number 3 is a symbol for a lamp. So if you answered C, you are correct. It looks like a lamp, doesn't it? Yeah, it sure does. Okay, what is component 4 in figure T1? Component number 4. Well, again, I kind of described the circuit before. That just kind of indicates your long side is positive. Your short line indicates the negative, and this might be two batteries in series. And if they're 1.5 volt batteries, and they're supplying 3 volts, that must be a 3 volt lamp. So what you have there basically is a battery for component number 4. Your answer is C. Final answer. And for $1 million, I wish. Okay, what type of switch is represented by component 3 and figure T2? Now, I am going to, let's see, where is that? Here I have kind of a little bit of a graphical depiction of what the different types of switches are. This is a single pole, single throw. In other words, you're either in an on state or an off state, um, but it's a single pole. This is your pole right here. And who dat? Who dat? Oh, Cohen. Hi, Cohen.
Hello, sorry I'm late.
No problem. No problem. You can always catch up with the recording later on. And then you have the single pole double throw, which means that um, you can throw this switch. It's going to do a different function. It's going to connect to something and not just be in an off state. It's either going to be connected here or there. That's a double throw switch. This is a single throw. It's either on or off. A double pole single throw switch is you have two poles or two leads in and out, and you're controlling two circuits simultaneously with a double pole single throw, and they're either on or off. With the double pole double throw, again, you're using two uh, incoming circuits to control the status of four different items. Um, so in one state, these would be active, and in another state, these would be active. So that's predominantly what your different types of poles and throw switches are. Um, this is a little representation of the different types of buttons that are out there. You have little dip buttons that would be a single or a double pole, single throw, possibly. I don't know why they have the dynamite plunger in there. You have a push button. Um, so this indicates here a single pole, single throw, normally open. This indicates it's a single pole, single throw, normally closed or active. And you can kind of get that same kind of indication by looking at these as well. Rotary switches, slide switches, push button switches, toggle switches. There's all kinds of different types of switches out there. Let's see. Did I have any others? There's another. Yeah, explains it. I'll put these up there as well. This gives you a little bit more descript of the different types of switches that are out there. So we'll put that in there. So having looked at that, what type of switch is represented by component 3 in figure 2? And just by looking at it, we see that we have a single pole, and it's either normally open or normally closed. Depending on where it is, it's either in an off state or an on state. In this case, it happens to be a single pole, single throw. Your answer is A. It is single in both senses because you see only one wire going to the switch and only one single contact point. Okay, what is component 4 in figure 2? All right. Um, you've looked in the book. It's a rather easy thing. You can see that there's two coils there. You got one here and you got one here, and it um, when you have this type of configuration, what it's typically doing is that it's taking a like a power circuit. It's actually an isolation component from the rest of the electrical circuit, and it will transform or transfer the voltage, the electrical power from one coil to the other. So this is a transformer, basically. Your answer is D. What is component 6 in figure T2? 6 is right there. Oops. Any rate, that's an easy symbol. Again, it's a capacitor. It almost looks like a battery. And in a sense, remember I was saying once before that I used to pull jokes on people and charge up these capacitors and just give a momentary jolt if you picked it up and touched both leads at the same time. So it has a capacity to store a potential or a charge. So it's called a capacitor. So what is component 8 in figure 2? Then we look over here at component 8 and we see that familiar look of what might be a diode. You get your anode and cathode, but it has two little arrows pointing away from it, which indicates that that is a light emitting diode. Your answer is D. A lot of our electronic devices these days do have LEDs in them. Um, on my refrigerator, I mean, I walk into my kitchen and my kitchen's practically lit up by stuff on my refrigerator or my stove or my microwave. I've got my uh, modems in a little room off from the kitchen, and of course they little flash on and off, and little LEDs and everything of that sort. So they're just about everywhere in my house. What is component 9 in figure T2? Component 9 is that thing right there. And as we can see, that little zigzag line, we automatically know that that's going to be a resistor, not an inductor. But what it actually is with this little um, line here with the arrow on it, that indicates that it is a variable resistor. Your answer is C on that. And of course, formally, it is called a potentiometer. Could very well be the volume control on your handheld. Okay, which of the following displays an electrical quantity as a numeric value? Now, if you answered C, you are correct. It is a meter. Um, it shows an electrical quantity as a numeric value. And real quick, I'm going to kind of show you. I showed you some digital meters the other day. I do have this nice little Weston analog meter. And so when I test things, the needle moves around and gives me an indication of what value is I'm looking at. So this is a pretty cool little meter. I've had it for a long time. And while I'm at it, um, some circuits that I've put together here. I did this for a little project for a little play. I built some components. This is called a breadboard, and it's used for testing out circuits. If you know, before you actually build um, an actual printed circuit board, a lot of times things are tested on a breadboard like this, and we have individual components. Like right here, I have LEDs lit up or lined up, a couple capacitors, LEDs over here, some other lights, some timer circuits, integrated circuits, and resistors and things of that sort. And all it really does is when I apply power to this, is that it just in various ways it just lights these lights up, causes them to blink and do all kinds of nifty things in a sequence. And so that's what a breadboard looks like for your typical circuit testing and building. So, thought I would share that. Let's see, what else do I have? Another type of meter to share is this little portable SWR meter. And this thing's rather old. I'm not even sure if it still works or not. But it has a switch to show the forward and the reference. When you put it in reference, that's where you kind of tune it to tune it to calibrate it basically, and then you'd throw it to SWR for the forward power and key the microphone, and it would indicate what your SWR is going out from your radio for mobile installations. Another meter. This is a little older. This has several different indicators on it. I have SWR over here. Also, it can tell me the modulation and the actual power output I'm putting out from my radio. Has different controls on it for different functions, calibrating for the SWR and things of that sort. This is just one of the meters that I have of all the ones that go on the back of my radios before the signal goes out to the antennas. Back to sharing. See, this is another breadboard here too. This is another little circuit that has an LED. This right here has a little 555 timer. This, I believe, might be a light photo detector that if the light goes out, this light comes on. If you're like your electricity in your house, this light would come on automatically. There's another simple circuit and power. Pretty much it's the same thing that was there before, except it doesn't have that little photo detector on it. All right, getting back to basics here. And again, we have another chart about schematic symbols. I believe you have this in your book as well, and gives you some indication of some of the more common things you might run into while active in the hobby. But these are things to know and kind of understand. So what is a relay? Well, a relay is kind of like a switch, but it's controlled by something else. So it is an electrically controlled switch. Your answer is A on that. It opens and closes by current passing through a coil, and it creates an electromagnet. As soon as the coil is energized, the switch goes from one state to another. So in one of my houses, I had put in a few things like this. If the power should go out in my house, they were all battery powered. The power went out, it would the relay would de-energize, and it would actually latch in a state that would remain, that would keep the battery-powered lighting on until I manually reset it. Okay, what type of circuit controls the amount of voltage from a power supply? Okay. Um, you have to have, it's very important to make sure that the voltage in your power supply is well regulated. So you want to have a good regulator in your power supply so that you don't exceed the amount of power needed to power up your radio equipment, typically 12 volts DC. Um, a lot of these you'll find in these circuits they'll have 16 volts, but the 16 volt transformer, it takes the 110, 120 volt AC from your house power and steps it down to typically around 16 volts thereabouts, and then it of course will rectify it from an AC to a DC, and you go through some filtering and things like that. But then you have a regulator circuit that actually maintains a consistent voltage from your power supply so you don't tear up your equipment. Okay, what component is commonly used to change 120 volt AC house current to a lower AC voltage for other uses? Of course, I pretty much just answered that for you, and it's a transformer. Your answer is B. It takes 120 volts, it'll step it down to a lower AC voltage on the secondary winding. Yeah, your primary, the applied 110, 120 volt AC typically goes in on the primary, and your secondary is the step down portion for the lower voltage. Okay, what is the name of a device that combines several semiconductors and other components into one package? Well, again, these are all discrete components, discrete devices, all packaged into uh, a single package. And in other words, they're all integrated. So your answer is C, it's an integrated circuit. And I kind of showed those to you just a little bit ago on the breadboard, what an integrated circuit looks like physically. And they can contain up to thousands of semiconductors in one nice neat little package. Okay, what is the approximate amount of change measured in decibels of power of a power increase from 5 watts to 10 watts? Now, now we get into a little bit of calculation um, as far as power measured in decibels, and you're going from 5 watts to 10 watts. You're actually doubling the power. If you're transmitting 5 watts, and then you double it to 10 watts, you basically increase your out amount of power by a certain amount of decibels. And when you double, it's typically 3 dB as um, as a standard. So if you halved your power, say from 5 watts to 2.5 watts, you would get a 3 dB decrease. In this case, we're doubling the power, and so we have a 3 dB increase. Your answer is B on this. What is the approximate amount of change measured in decibels of a power decrease from 12 watts to 3 watts? Now, we're cutting it in half for from 12 watts to 6 watts would be a minus 3 dB. And then if we cut it in half again from 6 watts to 3 watts, that's another 3 dB. So your total in that would be a minus 6 dB. It's a 4 times decrease. Oh boy, check this out. There's some formulas for you to kind of mull on for a little bit. That's in your book as well. Um, if you understand logarithms and exponents and base numbers and things of that sort, you would use these formulas to calculate your dB um, and power comparisons. If dB equals 10 log, 10 to 10 base times P1 divided by P2, then what power ratio is 20 decibels? So you follow the progression along there, and you finally come out to 20 dB means P1 is 100 times P2. This you don't have to remember on the test, so it's just there for reference. What is the approximate amount of change measured in decibels of the power increase from 20 watts to 200 watts? However, you will need that formula information, but probably best to just remember this one because you're going to be measuring the amount of change measured in decibels of a power increase from 20 watts to 200 watts. It's going to be 10 dB. So 20 times 10 equals 200. Going it's 10 times increase in power. What does the abbreviation LED stand for? Well, we've talked about this before. So if you answered B, light emitting diode, that's exactly what it is. They come in various colors. They can be green, red, amber, or even clear. Um, you have a lot of modern lighting nowadays that has been slowly replacing even the we've had the fluorescent lighting replacing our incandescent lighting, and LED lighting is a little bit more prevalent, becoming more prevalent, and they've become more efficient to the point where they really give off quite a bit of light. So I have some LED lighting in my house, but it also causes a little bit of interference on the radio. I don't know how they're going to stop that. So, which of the following is commonly used as a visual indicator? Again, we were just talking about that. Your answer is an LED. We give you a visual indicator. You have that on your radio. There's an LED. You can have a transmit or a power indication or something of that sort. It's a visual indication by having an LED or a light emitting diode. Answer is A. So, what is another way to specify a radio signal frequency of 1,500,000 hertz? Careful with this one. There's only one correct answer. If you answered A, that is correct. It is 1,500 kilohertz. Another way, it would either be 1,500 kilohertz or 1.5 megahertz. So from hertz to kilohertz, you move your decimal 3 places to the left. In this case, you would go from here to here, and then 1,500 would become kilohertz. And then if you moved it 3 more places over here, you would be 1.5 megahertz. Okay. If a frequency display shows a reading of 2,425 megahertz, what frequency is that in gigahertz? So we're going from megahertz to gigahertz. Again, we're going to move that decimal over 3 spaces, and you're going to come up with 2.425 gigahertz. How many volts are equal to 1 kilovolt? Well, we know that a kilo means 1,000. So then in that case, it would indicate 1,000 volts. A kilo means 1,000. 1 kilovolt equals 1,000 volts. Answer is C. If an ammeter calibrated in amperes is used to measure a 3,000 milliampere current, what reading would it show? Now remember, it's calibrated in amperes, and you're measuring a 3,000 milliampere current. And we know that automatically, a milliamp is a million, I believe, million amperes, 3,000. Your answer is C. Okay, 1 milliampere equals 1,000th of an amp. Therefore, 1 ampere equals 1,000 milliamps. Divide 1 milliamperes by 1,000 to convert to amps, or move the decimal point 3 places to the left. That's all you got to do. It's pretty simple stuff. As long as you remember you're moving a decimal point three spaces at a time. Okay, here's another easy one. Which of the following frequencies is equal to 28,400 kilohertz? So we look at D, we automatically know that 28.4 kilohertz is incorrect. We also know that 284 megahertz is incorrect. And we know that 2.8 megahertz is also incorrect because you're only moving your decimal point 3 spaces to convert to megahertz. So the correct answer is A, 28.4 megahertz. Okay, which of the following is equal to 500 milliwatts? Remember, milliwatts is predominantly 1,000 watts, and we're looking at half of that. So we're looking at 0.5 watts, half a watt of power. How many milliamperes is 1.5 amps? So we're going to go ahead and move our decimal place. We're going to move it to the right 3 spaces, and we come up with the answer being C, or 1,500 milliamps. How many microfarads are equal to 1 million picofarads? A little bit more difficult here. Um, if you understand what a picofarad is, contrasted to a microfarad, then you know that your answer would be B, or 1 microfarad is equal to 1 million picofarads. Move the decimal point 6 places to the left. How many volts are equal to 1 microvolt? Again, we're looking at some very easy stuff. A microvolt would be actually 1 millionth of a volt, or answer A. Correct. You're right there. Micro means 1 millionth. Which of the following types of solder is best for radio and electronic use? One thing you never ever want to use is acid core solder. Never use that in electronic circuitry. What we actually use is rosin core. Um, it's not a corrosive solder, so we always use rosin core solder in electrical or electronic components. Okay, what is the characteristic appearance of a cold solder joint? Boy, I tell you, even some new equipment can get a cold solder joint, and it's very, very prevalent, very obvious, and very noticeable once you get in and investigate. If you've got an intermittent connection, you discover what's known as a cold solder joint. It's going to have a very grainy and dull surface, um, not very shiny. You want your solder joints to be nice, bright, and shiny. But a grainy, dull look indicates that it's poorly soldered, and it's called a cold solder joint. Tom mentioned last night that at the next meeting, he's going to demonstrate soldering techniques. So if you're interested in that, um, come along to the meeting. The meeting is on, let's see, the 14th. Yeah, the 14th of March. That's a Thursday night, and it's going to be at 231 Howard Avenue, Abundant Life Church, just down from the um, Altoona Hospital. And we meet at 7 o'clock. All right. Which of the following measurements are commonly made using a multimeter? Well, a multimeter doesn't really do your SWR or RF power. It doesn't really do anything for signal strength or noise. It doesn't check for impedance and reactance, but it does, however, allow you to measure voltage and resistance. And like I said before, every amateur operator should own at least a multimeter. And you can measure voltage, current, resistance. You can also check continuity as well. This might be a good time to maybe show a little bit more test equipment that I have. I'm going to stop sharing just for a moment. We talked about antenna analyzers the other day, and that is my antenna analyzer. I kind of pulled up a picture of that. And this display predominantly, it shows an SWR reading. It also has other indications on this meter. It'll indicate things in this display. You can select the various bands here and do the fine tuning, and it'll determine where the resonance of an antenna is. Frequency will show up here in the display. You can check the SWR. It kind of gives you an indication. It'll also show up here in the display as well, and it determines. It'll give you the kind of general condition and the resonant frequency of a wire antenna, basically, or any antenna that you've got working. Um, Another device I have for testing is this nifty little cable tester. It's a little dusty. It doesn't get used very often. With this, I can test microphone cables, telephone cables, some USB cables I can test, and it gives me a visual indication through LEDs by no less, of things like that. On the side here, again, I have different other types of connections. I can even check coaxial cable with a couple adapters and audio cables, things of that sort. And I just plug them in. It's two-sided, so you can see that stuff. My coaxial cables right there. Plug them in, and I can test them to make sure that they're operating properly. And I just ordered some jumper cables. That's coaxial cable right there. These are pre-made, and I'm going to go ahead and test those on my meter here and make sure that they're good. I received them in good condition, and pretty nifty test equipment around here. Takes a while to accumulate this stuff. All right. Okay, which of the following precautions should be taken when measuring circuit resistance with an ohm meter? Now, you got to be really careful when you're doing this. You can't just take and throw your meter on uh, the resistor or check really any component that you want to check passively if you have voltage turned on or applied to the circuit. So you want to make sure that the circuit is not powered B before you check anything. The ohm meter will be toast if you try to check anything that is energized in there, and basically your meter will be no good. Okay, which of the following might damage a multimeter? Well, we were just kind of talking about this. Again, this is one of those questions that's worded a little bit differently in there. And C is the correct answer. You are going to damage that brand new analog or even the digital meter uh, by measuring voltage if you accidentally leave it in the ohms reading setting. Of course, if you're checking voltage, that's one thing. Just make sure you have the right settings set on your meter before doing anything. It's best that you actually power your stuff off if you open up the cabinet of your radio or whatever electronic piece of equipment you're working on. You want to make sure that the power is off anyway. You don't even want to shock yourself. And I've done it a few times accidentally, not on purpose. But voltage can do some damage. So, what is probably happening when an ohm meter connected across an unpowered circuit initially indicates a low resistance and then shows increasing resistance with time? Now, this is kind of an interesting one because what's happening is that your circuit could have a capacitor. Again, a capacitor has some kind of capacity to hold a voltage. Um, Good circuits, well-designed circuits, will have a bleeder resistor that when you power off your equipment, um, the capacitor will discharge and not hold that potential within it, and which can sometimes cause you a little bit of a shock as well. Okay, well, there we are. We got through all of that, and within the hour, um, we talked about antennas and things of that sort. Anybody have any questions they want to ask? And do we want to? I mean, I hadn't planned on doing it tonight, but we can. We can jump right into um, topic 20. Since last night we covered topics 16, 18, and 19, um, and I'd only planned to do back up and do 17 tonight, but we did talk about antennas, and the last topic to be covered is topic 20, and it has to do with safety. It's only 35 slides. This was 45, so we have plenty of time to do it if you want to jump right into it. And that way, if you want, we can dedicate all of Thursday for review. I'm going to, as I mentioned earlier, I want to pull out particular slides which I believe might be problematic for some of you, and create a whole different little slideshow just for review on Thursday evening. And if there's any particular thing that's kind of throwing you, let me know. I'll pull slides for that. We'll cover that. And maybe we'll just do Thursday completely as a review session only if you want to go ahead and continue with safety this evening. So, what does everybody want to do? Everybody, you want to do safety tonight? John, Herb, Dave, good. Cohen, Mitch, all right. Well, we'll just jump right into the last topic then and do that. Let me close that, and that would be starting at slide number 417. So let me slip down to 417. All right. Now, of course, this is the last topic to be covered, but certainly not the least important. Safety is very important when it comes to your ham radio. We've kind of touched on this throughout the course as it is, and just recently in the last topic we covered has to deal with how you service your own equipment, how you test it, things of that sort. But it also extends out to the antennas. So we're going to move right into this. What is a good way to guard against electrical shock at your station? Um, Sometimes your cabinets will carry a potential on the outside of them. Um, my old HT40 transmitter was one of those. It didn't really have a third wire for a ground connection. It was just a two-wire connection right into the wall, and it sometimes carried a little bit of a potential. And if I touched it just the right way, I could get a slight shock out of it. But a good way to guard against electrical shock at your station is A, use three-wire cords and plugs for all AC powered equipment, or B, connect all AC powered station equipment to a common safety ground, or C, use a circuit protected by a ground fault interrupter, or D, are all of these choices correct? And that is right. If you answer D, you are correct. They are good wiring techniques, and that's one of the things I had to do was ground the cabinet of my HT40. Um, Eventually got around to it after about a dozen or so times of getting a little mild shock. I said, "Well, it's time to ground this thing," so I did. So good wiring techniques are really good to know to keep you safe from some of these things. Hi, Tom. I don't hear you.
I'm there. Good evening.
Good evening.
Sorry I'm late.
No, it's no problem. Do you have the address to the 911 center?
I will.
Okay. Um, we're a little ahead of schedule here. We're going to go ahead and cover the last topic, and that's safety this evening. And we're going to dedicate Thursday, um, maybe for about an hour, on review of what we've covered so far. So that's what Thursday is going to be dedicated to. If you can get in on the first hour, that would be great, and or you can just pass along the address to me, and I can pass it along to everybody. If you want to just send me an email, it doesn't matter to me one way or another. Um,
615 4th Street.
there you go. 615 4th Street. All right. Now, one thing about the test, you'll need two forms of ID. Um, if you have an FRN or a number already assigned by the FCC, if you know that, that would be a good thing to have. What else are they going to need, Tom?
That's it. You may bring a calculator if you want to use one.
Mhm.
Two forms of ID. The FRN will fill out the 605 form on the spot. That's pretty much everything.
Okay, thank you. And keep in mind, um, the test session is $15 to cover administrative cost and materials, I think. Is that right, Tom?
That's correct.
Yeah. If by chance you don't pass the first time, um, and I'm confident that everybody's going to pass, let's say you only miss by one or two questions, you can take the test over again. You'll get a different set of questions, however, and there's just selected just one or two questions from each base topic that are asked on the test. And so and most of them are pretty much straightforward and common sense, but you can take the test over again, usually, typically, if you miss by 1 or 2 questions, or if you feel like you can do better on the second one, you just won't have the same questions that you had initially. You'll get a whole new test to work on.
And that requires an additional $15 fee.
Does it?
Yes, it does.
I thought it included. Oh,
If you take the test over again, it's like walking through the door as a brand new person. You
I
pay
was
another
not aware.
$15 fee.
I was not aware of that.
I'm sorry, that's harsh, but that's what it is.
Okay. Sorry, guys.
Now, the Cambria group, they'll let you take it. They'll let you take it 6 times for one fee, which is 0.
There you go. You might want to wait until Friday and go down to Johnstown. I don't know, but at any rate,
I'll be leaving Altoona probably about 4:45, which will put us in Johnstown at 6 o'clock, where the test is, and they'll administer the test, and then the Cambria Club meeting is afterwards.
okay.
If you want to drive separately, that's fine. I'll meet you there, and we'll take things from there as far as testing. Same thing. Bring your FRN and 2 forms of ID, and you're good to go. If you want to ride over with me, that's fine. The club meeting is afterwards, and then about 8 o'clock, when the club meeting's over, we usually go out and get some dinner. So it'll be an evening of it. But call me if you want the details.
Okay. Thank you, Tom.
You bet.
All right, moving right along here. In the United States, what is connected to the green wire in a 3-wire electrical AC plug? Mitch knows this one by heart. It's the equipment ground. Green is for ground. It's the 3-wire electrical plug should always have the ground connector in place to provide safety. Answer is C. What safety equipment should always be included in home-built equipment that is powered from 120-volt AC power circuits? This is probably a no-brainer. It's it's something for your safety, and it should always include a fuse or a circuit breaker in series with the AC hot conductor. Answer is A. What is the purpose of a fuse in an electrical circuit? Again, it's one of those that, we just kind of covered that. And it basically it is to interrupt the power in case of overload, and it will protect you as well. In that case, fuses provide an on-purpose weak link to protect the system from too much current passing through. So the weak fuse element will melt at a specific current and interrupt the circuit. So why is it unwise to install a 20 amp fuse in place of a 5 amp fuse? Boy, I've seen people put in pennies and bolts and screws and iron bars. They don't even mess with putting in another fuse. But at any rate, what will eventually happen is that it will cause too much current and cause a fire. So you want to make sure that if your 5 amp fuse blows, you want to replace it with a 5 amp fuse. And if it blows again, then you've got some issues that you've got to do some troubleshooting and go in and find out what's going on that's causing excessive current to occur. I got a power supply right now that I got to fix. I think the crowbar circuit went bad in it, and thus it does not function properly. Okay, what kind of hazard might exist in a power supply when it is turned off and disconnected? I hear Kevin on the radio over here. At any rate, what hazard might exist in a power supply when it is turned off and disconnected? Now, I kind of touched on this topic before. Again, we're talking about those nice little sneaky capacitors. They have a capacity to store some electrical charge. So, especially the high voltage capacitors, they'll many times store a charge for quite a while after the equipment has been turned off. There are some techniques that you can use to make sure that that capacitor is discharged properly. Uh, Once you turn off the power and disconnect the power from the wall, you can short across the capacitor to discharge it using a screwdriver and insulate with an insulated handle. Some equipment, like I say, will also have what's called a bleeder resistor that when the power is disconnected and turned off, it'll automatically bleed the power or the charge out of the capacitors so that you don't have the potential of getting shocked by them. Which of the following precautions should be taken when measuring high voltages with a voltmeter? Yeah. Um, Realistically, some ham equipment can have some rather high voltages in them. My 520 has that potential as well because it has tube finals, so it requires high voltages coming off of a multi-tap transformer. But one of the things you really want to make sure, a precaution I would have to take once that is done, once it's powered off, is to ensure that the voltmeter and leads are rated for use at the voltages to be measured. So unplug the equipment in question, fully discharge any capacitors with a shorting stick, attach your voltmeter probes to the test points in question, usually using alligator clips if necessary, and then reapply power from a safe distance. Safe, that means stand across on the other side of the room in case it blows up the meter. I don't know. My analog meter here, why is it doing that? Okay, something's going on here with my What are you all seeing on your end? Tom, what do you see?
What do you see?
Seeing a picture.
Seeing a picture?
What is it, 7
Yeah, we see a picture of your radio.
Okay,
Okay,
something's
circular
wrong.
picture.
It's not
It's
sharing.
not sharing.
Let me stop. Okay. I don't know what's going on here.
Is your camera turned off?
Well, my camera is off, but I was trying to share the screen and it just stopped sharing all of a sudden. And my camera isn't functioning. Let's see here. Stand by, everybody. I'll try to get this on. See if I can activate the camera here real quick. It's not activating. Oh, there it is. Okay, well, this is kind of strange. All of a sudden it quit. And I don't know why. Huh. This is really weird. Oh, I've got some technical issues here, apparently. Oh, buddy, oh, buddy, oh, buddy, oh, buddy. This isn't good.
What happens to the rest of us if you reboot?
Probably have to redo the link, and I have to paste it all together. As far as I know, I don't know. Hopefully I won't have to do that.
I just wondered if you dropped out, can we just hang out here and you join us back in, or?
I can try to do that if you give me a moment to do it. Let's see what happens here. Stand by, everybody. I'm not sure if I can still do the presentation, though. That's the thing, since I am the moderator, and it's not. Okay. Well, I see you, Tom. See, it's not activating my camera for some reason. I'm not sure why. Wow.
If you can't share your screen, we can't see the slides.
Exactly. All right. Let me drop out of here again and see what happens. Let me do this before I drop out. Let's see. Let me bring up the email that I sent out because that has the link. All right. It's not activating my camera. All right, folks. Let me drop out of here, and I might have to send you another link to continue this. Just give me a few moments here. Um, might have to stop the broadcast too. That's going to disrupt the video, and I'll have to piece it back together. Download it and piece it back together. I hate to do it, but I'm going to have to, it looks like.
Do you want us to stay here, or should we disconnect and wait for the link?
Stay here. Let me see if it works.
Okay.
Yeah, I'll see if it works. If not, I'll send a link so everybody keep an eye on it.
Thank you.
Bye.
I like that revolver. I got a couple like that.
It's a black powder cap and ball pistol that I got from Brian's basement, and I don't know if it's an antique, if it requires to be registered, and I don't even know if it's in shooting condition.
Hey, I'm back.
Well, if it's black powder, it does need to be registered.
Does not.
No, you can actually go out and buy them. You know, if it's a replica or an antique, they don't consider them firearms.
It's marked on the barrel, black powder only. I'm guessing it's about a 32, but I don't know.
Looks more like a 44 or a 36.
Okay, is everybody hearing me okay?
Yep.
That's it,
All right.
44.
Let's try to do this again here. Sorry about that. All right. Does everybody see the share?
No,
Yeah.
I do now.
Okay. All right. We'll mute some mics here and well, we'll pick up. Sorry for the little interruption there. I don't know what happened, but just went bleh. Any rate. I think I'm at the right slide. I'm not real sure here. Okay. Yep. Here we go. Which of the following precautions should be taken when measuring high voltage with a voltmeter? We did kind of cover that, and your answer is B. Um, you want to ensure that the voltmeter and leads are rated for use at the voltages to be measured. So, what health hazard is presented by electrical current flowing through the body? Ooh, well, could cause injury by heating tissue. Yeah, that's a good possibility. It also may disrupt the electrical functions of your cells. It may cause involuntary muscle contractions. And of course, all of these choices are correct. Your answer is D. And I've had the unfortunate experience of having involuntary muscle contractions. But that was way back in middle school, I think, that happened. But at any rate, all those things can happen to you. What can happen if a lead acid storage battery is charged or discharged too quickly? Um, that is something that can present itself as a hazard as well. Uh, Not only can the battery overheat, but it can also give off flammable gas or even possibly explode. So, overcharging any type of battery these things could result as well. All right. Let's see. Which of the following is a safety hazard of a 12-volt storage battery? Um, there is a particular safety hazard, and you have to be very careful when you store batteries, and that is the shorting of the terminals can cause burns, fire, or an explosion because it presents a high current. If you short across those terminals, it causes the high current to flow, and you have a quick discharge of the battery. It can do a lot of nasty things. So, which of the following is an important safety precaution to observe when putting up an antenna tower? Um, yeah, towers can be tricky, particularly if you have things around. You want to make sure that you really don't have any obstructions, and those obstructions include having electrical wires overhead. The last thing you want to do is uh, put in the concrete pad for your tower and raise the tower, only to realize then that overhead is the electrical wires coming into your house, and bzz, there there you go. No more me. So you got to make sure that you're clear of power lines and you have a very good distance from any type of power leads whatsoever from any of your antennas or your tower. There is a power line safety video on YouTube that you can search, and that can give you a little bit more information right there as well. All right, what is the minimum safe distance from a power line to allow when installing an antenna? Well, it really, when you look at these, um, the only really safe distance is making sure that you have enough distance that if the antenna falls unexpectedly, no part of it can come closer than 10 feet to the power wires. So, very important stuff. All right. Why should you avoid attaching an antenna to a utility pole? Again, it's not really a very smart thing to do because the antenna could contact the high voltage power lines. So don't attach your antenna to the power company utility poles. Um, Not only does it have that potential, the electric company might not like it either if they see it, and they'll take it. They may just cut it down or tell you to take it down. What is a good precaution to observe before climbing an antenna tower? Okay. There are certain precautions that you need to take to climb the tower safely. I've been on many a many tower myself. Um, it's no fun even with safety equipment, but the safety equipment is definitely a must. Your climbing harness, um, and make sure that you have your fall arrestor in place, and even safety glasses are a good idea.
And make sure you have a buddy who can pull your beer up to you on a rope.
Yeah, that's right. Um, and that you should always have a bucket handy too, so that whatever tools you need can be safely pulled up to you and lowered back down. It's also a good idea that even those standing below, especially those standing below, is to wear a hard hat. Under what circumstances is it safe to climb a tower without a helper or observer? And I think Tom just kind of alluded to that anyway. But under no circumstances, never should you work on that tower without somebody available or having a helper nearby. And they recommend not going more than 2 inches off the ground. Of course, I've been up on my tower once and no one around, and I won't do it again because it gave me the heebie-jeebies. When should members of a tower work team wear a hard hat and safety glasses? Well, this should be a no-brainer at all. Your answer on this is C, at all times when any work is being done on the tower. So you want to make sure that everyone's wearing hard hats and safety glasses, and to watch out for falling hammers, screwdrivers, antenna parts, and other things that can cause injury. So what is the purpose of a safety wire through a turnbuckle used to tension guy wires, or guy lines rather? Okay. Uh, the turnbuckle is a pretty neat little thing. I'm glad they were invented, but it helps to prevent loosening of the guy line from a vibration. So your safety wire should be inserted through the turnbuckles to prevent loosening. Nuts and bolts subject to movement, such as tilt-over tower hinges, should be fitted with safety wire as well. Your answer is B. So what is the purpose of a gin pole? Certainly not to mix your gin and tonic, or your not to play gin rummy or any of that other stuff. It is a simple little device that is used to lift your tower sections or antennas into place. Um, the gin pole would strap onto the side of the tower piece that's already in place, and it extends above. Part of it extends above the piece of tower that is in place, and you hoist the next section up and allows it to be held in place while you guide it into the proper position for fitting into the lower section that is already there. And of course, once that next section is lifted in and secured and put in place, then the gin pole would be disconnected, and you would go up the tower a little further with the gin pole and attach it to the top of the piece that you just put in place. And of course, that's presuming you have another piece of tower to go on top of that one. And then that would lift the next piece up. Okay, which of the following is an important safety rule to remember when using a crank up tower? Crank up towers are neat. I almost wish I had one here. But one of the things that to remember, these towers is exactly what it says. It's a crank up tower, meaning that it retracts down, and then when you want to use it, you would crank it up to its height, that desired height as far as operation is concerned. But it's not to be climbed unless retracted or mechanical safety locking devices have been installed. So if you were to climb up a crank up tower, even if it's partially or fully cranked up, um, you first off should crank it down if you want to work on the antenna on top. But if it is up, maybe you have a problem with it not coming down. One of the things is you want to make sure that each piece is locked properly in place, so that you're not on a top section and all of a sudden it decides to collapse and you're kind of stuck and wedged and pinched in between the sections. So that's one of the issues that you need to be cautionary about. Crank it down if possible. Which of the following establishes grounding requirements for an amateur radio tower or antenna? Okay, grounding requirements. Now, the FCC Part 97 rules covers a lot of things like, the operation of the radio, the frequency bands, different rules and regulations, but it has nothing as far as grounding requirements or, the mechanical safety and nuances of your equipment. So you really want to follow the local electrical codes. So before erecting an antenna, always check those electrical codes which address tower grounding and antenna installation. Typically, you want to drive an 8-foot ground rod into the ground and ground your tower. It also helps to protect from lightning and also discharge static charges in the air that might be there and get them down to ground. But the local electrical codes basically establishes the grounding requirements for your amateur radio tower or any tower for that matter. Okay, what is considered to be a proper grounding method for a tower? Okay, I think I just mentioned this really just a moment ago, and it's take a separate 8-foot long ground rod and do it for each tower leg, bonded to the tower and in each other. So if you have 3 tower legs, you're going to drive an 8-foot ground rod into the ground for each one of those that forms a triangle, and you're going to tie them all together and tie them to the tower as well. So what should be done to all external ground rods or earth connections? One of the important parts about grounding is that you want to make sure that the wire you use, and usually it's best to use the conductive strap. So you want to bond them together with heavy wire or a conductive strap. Which of the following types of conductors provides the lowest impedance to RF signals? Which of the following types of conductors provides the lowest impedance to RF signals? In other words, they pass more readily and easily. Typically, your flat strap is one of the best methods for grounding your equipment. It's usually a flat copper foil ribbon.
Hey, Wayne,
Yep.
had a little event happen here this week. City Water Authority came in and replaced my water meter.
Yay.
And they took out the brass electric water meter and replaced it with a plastic one. And then they made no provisions for bonding across the meter.
Oh, you're
And
kidding.
I was thoroughly upset because they basically walked away and left all the copper water pipes in my house ungrounded and
Wow.
didn't even notify me as to the condition. And
Wow.
just something to be aware about. Just because it's a copper water pipe doesn't mean it's grounded. Check it.
Yeah. Wow. That's unfortunate. What are you going to do to remedy that?
Well, I already fixed it. I got 2 straps and a piece of number 6 wire and 2 clamps, and I put anti-oxidation compound on it after cleaning up the pipe and getting it bright and shiny, and I regrounded it. But how many other people are going to even know to do it, let alone take the time to get the stuff and make the repair?
Exactly. Wow. That's interesting. Oh boy, which of the following is good practice when installing ground wires on a tower for lightning protection? A good practice, again, is you want to make sure that your connections are as short as possible and direct. You don't right angle bends and sharp turns and everything kind of tend to mess things up. So you want to make sure that they're as short as possible and go directly to Earth. So, which of the following is true when installing ground conductors used for lightning protection? So, you're installing grounding conductors used for lightning protection. Again, this is not dissimilar to the previous question. And I just mentioned you want to make sure that your sharp bends must be avoided. So, you run those grounding conductors and you want to be as short as possible and you want to go directly to the earth. No bends. So, which of these precautions should be taken when installing devices for lightning protection in a coaxial feed line? Coaxial feed line is a little bit of a different animal, but you want to make sure that proper precautions are taken for lightning protection when using a coaxial feed line. So you mount all the protectors on a metal plate that is in turn connected to an external ground rod. Very simple, basic stuff. Lightning protectors must be grounded to an external ground in order to be effective. Okay. What factors affect the RF exposure of people near an amateur station antenna? Oh, they all become brain dead and become zombies and they roam the earth and because they were exposed to all that RF. Actually, all of these choices are correct. The effect of RF exposure, frequency and power level of the RF field, distance from the antenna to the person, and the radiation pattern of the antenna. Um, all those are important factors in evaluating the environment or the environmental effects of the emissions around people. That's why you see people wear tinfoil hats because they're afraid of RF exposure. All right, why do exposure limits vary with frequency? This is an interesting question in and of itself. Um, and the thing is that depending on the frequency, depends on how much the human body is actually going to absorb. So the human body will absorb more RF energy at some frequencies than at others. So at certain wavelengths, say around 6 meters, the human body absorbs more RF energy. On lower frequency worldwide wavelengths, the body absorbs less RF energy. And this kind of piggybacks a little bit on some of the concerns people have when using cell phones, because cell phones are basically a radio. They are a full duplex two-way radio. They do emit an RF signal, and they're way higher in frequency than 6 meters is. So, the human body might have a little bit more of a tendency to absorb that RF energy and cause issues. Somebody have a
Just on
comment?
a side,
Yep.
yeah, just on a side note, I've heard people have the same, let's say, problem with the electrical meters and such. They say that there actually does produce a RF frequency that does affect them.
Yeah, you're talking about the smart meters.
Yes, new smart meters. Yes.
Yep. Yeah, I really push back on this quite a bit, the smart meter issue. I had specific questions, and the power company couldn't answer them. Neither could the manufacturer of the equipment and things of that sort. They did have some information, but it wasn't very technical oriented. It was more information for the layperson um, that basically said, "Oh, don't worry, it's negligible, nothing, blah 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 blah." But I had really specific questions. Tom came up and brought a spectrum analyzer, and we did some measurements and everything. By the way, Tom, I still have that information on hidden away. And maybe if you get a chance, maybe around field day, bring your spectrum analyzer up, and we can check and see what differences there might be with the smart meter in effect. And I really, I believe I really could have pushed back long enough on this that I wouldn't have one now, simply because they could not answer my questions, and they were valid questions. And they couldn't answer them. They couldn't answer them. And so they kept pushing back the installation and pushing back the installation. I probably could have had this still going on for a while, but I said, okay, fine, bring it in. You can't answer my questions, but know this, that if there are issues, and I had to deal with my radio equipment, and the effects that my radio equipment might have on it. Fortunately, my antennas are pretty much on the opposite end of the house, with regard to where the smart meter is located, and what is the potential interference that is going to cause, say, on my Wi-Fi, because it does use frequencies, and it uses subharmonics that can affect the ham radio frequencies as well as my Wi-Fi. And what is what is the remedy, for instance, if my ham radio equipment should cause it to malfunction? And I even sent them pictures of smart meters that literally burn the side of a house and burn houses down because they malfunction for one reason or another. Who is the manufacturer of these particular meters? These are answers, again, they couldn't provide me because they couldn't identify the particular meter that caused it. And there was no information on it that caught fire on the side of a house. So these are all legitimate questions that I was asking the power company and others that they literally could not answer. So, and I probably could have taken this right into Pennsylvania and their act, whatever act number it was. I don't remember what it is right now. But yeah, you're right. That can cause issues. Definitely. How much RF energy is being given to your body because of it.
Yeah, Wayne,
Yeah, Dave.
when they came out to put it in into my house, and I started going through this whole question answer and the whole thing, and the guy says, well, I can sit here and talk to you. I ain't gonna be able to tell you anything, but, and then he pulls out this sheet of paper and goes, but you got to let me do it, or you're coming, you're arrested.
Yeah, the guy came out and he was getting ready to put it in there, and I said, no, you're not going to put it on unless you can answer these questions. The guy looked at me. This was the initial time because I didn't even get a notification, and just some guy showed up one day and he says, I'm here to install your new meter. And I said, you answer me these questions and I'll let you do it. He couldn't answer me the questions, and I said, then you're not going to do it until these questions are answered. So he took off. And again, like I said, I went back and forth with several people, several places, and nobody could answer it. So I was able to kind of put it off for maybe about, I don't know, 6, 8, 10 months. And finally they called one day and I said, you still don't have answers for me, do you? And she said, no, I don't. And I said, well, I can take this to Pennsylvania to the whatever the department is out there in Harrisburg. And I said, we can kind of negotiate this and stuff like that. Or I can just say, come on out and put it in. And she says, that's up to you. Whatever you want to do, we'll do it. And I said, well, I have a feeling that nobody's ever going to be able to answer my questions. So go ahead and schedule me and bring it out. So they did. They brought it out.
They must have put mine in after they talked to you, because they already were armed with a piece of paper. It says now they're covered by law that you had to allow them to do it.
Well, that's Pennsylvania law. I know that was always in effect, okay, that there were no exemptions. However, people had been successful in not having, or to be forced to have them, however. And for whatever concerns, and I'm not sure, there were very few of them. But I can tell you right now that there are people in this state that do not have them installed. Anyway, thanks, Dave. All right, let's see. Moving right along. Which of the following frequencies has the lowest value for maximum permissible exposure limit? I think we just kind of talked about that at the previous one, and it happens to be 50 megahertz or the 6-meter band. Every radio frequency has different effects on the body, but the common tech class ham radio 6-meter band at 50 megahertz requires added distance between you and the transmitting antenna. Your answer is B. So what is the maximum power level? Let me get this up here. What is the maximum power level that an amateur radio station may use at VHF frequencies before an RF exposure evaluation is required? Oh boy. Well, the answer to this is 50 watts PEP at the antenna. And of course, again, that depends on where the antenna is located. Your answer is C. You're required to complete a routine RF radiation evaluation. And this includes VHF equipment operated by all amateur radio licensees. Nobody does it that I know of. Nobody does it because your VHF frequencies are on for the base station. They're high up, typically on top of your house, on top of your tower or whatever. And it's some of them are going to be more than 50 watts and some of them are going to be less than 50 watts. But nobody does this. But the correct answer to this is 50 watts of power or more before you have to have that evaluation done. I don't know who dictates that. Same people that force you to have smart meters, I guess. Which of the following is an acceptable method to determine that your station complies with FCC RF exposure regulations? Oh, boy. Okay. By calculation based on FCC OET Bulletin 65, or by calculation based on computer modeling, by measurement of field strength using calibrated equipment. Actually, all these choices are correct. Your answer is D. So apparently the FCC does have some RF exposure regulations, but they're not part of 97 that I know of. What do you think, Tom? Are they?
Yes. There, in 97 is the requirement to do the testing.
It is?
I believe so. Otherwise, there wouldn't be questions on the subject.
Yeah, when was it added?
A number of years ago.
Huh. I just learned something. Wow.
Yeah, they require you to do that, and that's why it's part of the technician license. And you know, it's not unreasonable for somebody to put an antenna up on the corner of their house and to have a 50-watt beam antenna only 20 feet away from the neighbor's bedroom, and you should at least be aware of what you're doing.
Oh, yeah, I see what you're saying. Okay.
Or another good example, you've got a 100-watt amplifier in your car, and you got a 5/8 wave antenna on your roof, and you and your buddies are all hanging out around your car, and you're transmitting, and you're only 3-4 feet away from people's heads.
That's true.
You ought to know to say, hey guys, I'm going to transmit using high power. You need to step a few feet away from the car. I mean, it could be significant over a long period of time, maybe like at field day or something.
Well, I think I'd just wait to see if their eyes started to bulge out.
Well, there's a military video where they hang a hot dog in front of a radar antenna, and
I've seen that.
it bursts into flames.
Yes, I've seen that. Go ahead.
Take it seriously, and if you have any doubts, ask somebody to help you with it.
Yeah, I agree. You never want to stand in front of a microwave dish, that's for sure. That's transmitting. Well, how about that? I did learn something tonight myself there, guys. How about that? So there are exposure regulations that I need to go and look at Part 97, obviously. So which of the following actions might amateur operators take to prevent exposure to RF radiation in excess of FCC supplied limits? Actually, relocating the antenna so that it's not within proximity is probably the correct answer here. In order to prevent the exposure in excess of the limits, you may need to relocate your antennas uh, further away or even higher, so that you're outside, the human body is outside the transmitting plane of the antenna, of the signal. I don't have to worry about it up here on the mountain. So I know that I'm putting about 50 watts, I think 50 watts into my antenna from my radio, and my antenna has a 6.5 dB gain. And so that's quite a bit of power, effective radiated power going out my antenna, way above what the FCC specified limits might be. And, but I'm not near anything. It's up on a 40-foot tower. What type of radiation are VHF and UHF radio signals? Oh, there you go. To look at this, it's, forget about the first three because it's really a non-ionizing radiation. When you have radio frequency energy coming from your antenna, it's really considered non-ionizing radiation. So it's altogether different from your X-rays, gamma rays, and ultraviolet radiation. Answer is D. So how does RF radiation differ from ionizing radiation radioactivity? We're almost done here, by the way, folks. So we'll be done here in just a couple of minutes. So how does RF radiation differ from ionizing radiation or radioactivity? RF radiation does not have sufficient energy to really cause genetic damage. Your X-rays, gamma rays, things like that, ultraviolet does have that potential. So unless you're transmitting ultraviolet, you probably aren't going to be significantly ionizing anything at amateur radio power levels. But operating under the legal power limits, your chances of causing any radiation are essentially zero. How can you make sure your station stays in compliance with RF safety regulations? Well, you need to really do an evaluation. You reevaluate your station whenever an item of equipment is changed. You might have that new 1 kilowatt VHF amplifier. You're going to be working single sideband and you want to do some serious DX with VHF. And so you put a 1 kilowatt amplifier on there. That's when you want to reevaluate when you have changed equipment. What is the definition of duty cycle during the averaging time for RF exposure? Now we're talking about duty cycle. The duty cycle happens to be the amount of time that your transmitter is on versus the amount of time that your transmitter is off. So your answer in this case is percentage of time that a transmitter is transmitting. So the less you talk, the lower percentage of time you're actually transmitting. And your total RF exposure will be less, at least for a given amount of power. Answer is C. If you're averaging the time for exposure is 6 minutes, how much power density is permitted if the signal is present for 3 minutes and absent for 3 minutes, rather than being present for the entire 6 minutes? Well, here again, we're looking at this. You're looking at it pretty much at a 2-to-1 type operation. So 2 times as much, just calculate the duty cycle, the ratio of on time to off time, and multiply that by the exposure during the on time to get your total exposure time. So 6 minutes divided by 3 minutes equals 2. or twice the power density. So why is the duty cycle one of the factors used to determine safe RF radiation exposure levels? Why is duty cycle one of the factors used in determining safe radiation exposure levels? Um, if you answered A, that is correct. It affects the average exposure of people to radiation. So your duty cycle is a measure of the amount of time your transmitter is working at full tilt. Lower duty cycle means less exposure to RF radiation. What could happen if a person accidentally touched your antenna while you were transmitting? Well, here again, it also depends on the amount of power that you're putting out there. But by and large, the simple explanation is that if you're transmitting and you have significant enough power, they could receive a very painful RF burn, even if they intentionally or accidentally touch the antenna. So there we go. We are at the end of the whole thing. And do we have any questions? I got a little confused there. I mean, there's some things that I learned in that little safety thing that I really wasn't aware of. And because I don't remember some of those elements from the last time I taught this class, it was
changed in 2013.
Did it? And I've taught since then, but I don't remember that being in the last class that I taught for tech class.
Well, the stuff was in the regulations, but there was no enforcement of it. And then on March 27th of 2013, FCC voted to advance its review and change the rules. And that's when they did that OET, Office of Engineering Technology, Bulletin 65, and they came up with standards. It was always in the rules to do it, but they actually came out with standards and levels and duty cycles and exposure times and distances, and gave you a practical way of determining whether you were posing a risk or not. So,
do you know how long it's been since I actually went through the entire Part 97 rules and regs? It's been a while.
Sure.
How long have I been licensed? 42 years. Back then, it was a simpler day, a simpler time. Oh, boy. Does anybody have any questions that they would like to ask? You can unmute your own mic and
just for your information, I don't have a smart meter.
How'd you get away with that?
Nobody around here does.
You're in Maryland.
No, but I don't know anybody down here that has one.
Where do you live? I thought you lived in Maryland.
No, I'm right outside Pittsburgh.
Oh, are you? Okay.
Yeah.
I didn't realize you were in Pennsylvania.
Yeah, I'm down by McHughsport.
Oh, okay. All right.
But no, we don't. I haven't seen a smart meter down here anywhere.
Your day is coming.
Just as long as they don't look at my panel inside the house. I got a 60 amp screw-in fuse panel.
Yeah, I told him ahead of time. I said, if this thing causes problems with my amateur radio equipment, my Wi-Fi, and other things around the house here, I said I was going to take a sledgehammer to it, and I was going to go out and start up my generator and power up my house with my generator. I warned him ahead of time that that's what I was going to do. So far, I haven't had any problems, at least that I know of. But what really appeals to me about the smart meter is that there is an application that allows you to monitor your power usage. And I haven't got that yet, and I need to explore that a little bit more to see what I can do to put an app out there to actually check my usage. Fortunately, the thing is, and the other question I had about this was that in order to collect the information, they have to use kind of a Wi-Fi connection. And in some cases, I know that, and I asked them specifically this, for my neighbors, are you using my meter? Because again, that's going to use my power, not really significant, but it's still the principle of the thing. If they're going to piggyback my neighbor's signals onto my meter, in order to monitor their power usage as well. But they said no. They have these things. You see them around here on the poles. They do have Wi-Fi collection points that broadcast directly from the smart meter on your home to those collection points on telephone poles in the area.
Now we do have that for our water meters.
Do you?
Yeah. They came a couple years ago, came through, and they actually mount a little antenna on the outside of your house, and it goes to, like you say, to a collection point. So they don't have to drive around getting it anymore.
Yeah. I mean, I think the technology is really cool. It's just, the concerns that we have as far as potential for interference, causing problems for excessive radiation in your house. Is very, very low voltage, very, very low power when you get right down to it. But the other thing that they can do too is that they can remotely shut off your power if they want to, and they don't have to come out to do it. So they can control you. They control you. That's what they do. They control you. What other information are they going to collect? What kind of TV shows do you watch? Things of that sort.
Yeah, they get all that stuff nowadays anyway.
I'm not supposed to let this out, and I generally don't, but I am a Nielsen household. So I have these little boxes by my TV that picks up signals, and they use cellular towers to transmit whatever signals that pick up that TV. When the TV stations or shows are broadcast, it broadcasts a little code that is inaudible, so like a subaudible tone, and the little box kind of picks it up from the speaker and then broadcasts that out to the cellular network and to their collection point to determine this household is watching this show or that show or whatever. And periodically I get called and they say, hey, we haven't been able to receive anything from Yap 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 TV, blah, 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 blah. And that happened shortly after we moved the TV to put up the Christmas tree. And I said, look, and they called me several times for this. I said, let me tell you something. I live on top of a mountain where I should have the best cell phone coverage in the world, and I don't. And I said, I moved my TV so I could put up my Christmas tree. Please don't call me again until after Christmas. Because then I'm going to put the TV back where it was and it should be all good. They haven't contacted me. So, but I'm not supposed to let that information out. Oh, well, I just breached it.
The new water meter can allegedly report water usage down to 1/100th of a gallon. So that's 1.5 ounces. That's a shot glass. And they apparently broadcast my water data every 6 hours on a radio on 220 megahertz. It's about 1.5 watts, and it transmits over to the Highland Park water tank. And it has a 10 or a 15-year calcium-based battery in the thing.
Oh, wow.
It apparently is a lot stronger RF field and things than the power meter is. But the next question is the gas company's going to come by here one of these days, and they're going to put remote reading capability on their meters. So that'll be a third one.
Yeah. I'm going to go ahead and stop this broadcast. Anybody that has questions, send me an email. Any suggestions for follow-up on Thursday, also drop me an email at wayne@n3lms.net, and we'll just plan on doing at least an hour review. I'll pull some slides together, and we'll do that on Thursday from 7 to 8.
I do have a quick question.
Yeah, go ahead, Tom.
Has anybody told Eric about the number of applicants he can expect Saturday morning? Or
I haven't. I don't talk to Eric. I haven't spoken to Eric.
Okay, well, he sent an email out today asking for a couple of more volunteers to help with the test session. And
Okay.
If we have a list of names and an approximate number of people that'll be taking the test, that would help him plan.
Okay, is this going to be at 9 o'clock on Saturday?
Correct.
Okay. Well, I can bring my credentials if I can find them. I think they're around here somewhere, and I can, because I'm planning to go ahead and be there as well.
Did you get that email, or should I forward it to you?
You can forward it to me because I didn't get it.
You got it. Done.
No, I did not get it.
I said, okay, I will send it.
Oh, okay.
Sorry.
Thank you. Thank you, sir. Appreciate it. See my signal generator there? That's a piece of test equipment. That's a signal generator. It's an audio signal generator that I can put into equipment and test audio signals through there. My little go bag with all my radios in there. It comes in quite handy. I throw in my radios and we go traveling, get on the cruise ship with that. My wife and I have radios to talk with each other and things of that sort. So I just noticed that in the background. All right. Anybody have any questions that they want to ask? Please let me know. Any particular topics that you're having particular trouble with. I want to be able to make sure that we review all the right stuff on Thursday so that you can be successful in passing the test. That's what it's all about here. And then your real learning begins. And I want to show you something real quick. I have here in my possession, I shouldn't be lifting with my left arm. I have the Radio Amateur's Handbook. This handbook is from 1960. Let's see, what is it? 1969 is when this Amateur Radio's Handbook was published, and subsequently in the 70s it got a little bit bigger. This was 1978. Okay, it's
Wayne, you're not transmitting.
I'm not. You don't see me?
Okay, I do now. You were minimized for some reason.
Oh, okay. All right. But at any rate, you can see that the 60 one is in the 60s versus the 70s is a little bit thicker. They're about the same size dimensionally from width, but that one's a little bit thicker. But let me show you this. Whoops. I bought a new handbook back in 2016. Not only is it a little bit thicker, but you can see that it is a different size. So this one contains, of course, a lot more information in there as things have changed in the amateur radio world over the years. Definitely covers things like satellite and digital communications. So I just really wanted to kind of share that with you, that if you really want to continue your learning after you get your license, I strongly suggest that you consider buying one of the handbooks from the ARRL, because it's just full of stuff, and it'll answer practically every question that you have. So at any rate, okay, we're after 9 o'clock here. We went a little bit over time because of our technical difficulties, but hope to see everybody on Thursday. We'll get another link together. So if we're good to go, give me a thumbs up, and we'll talk to you then. Have a good day, good week, what's left of the next couple of days, everyone. Thanks for joining me.